be interested in this, being a meteorologist, but a lot of you may have wondered whatever happens to common household items without atmosphere. Well, you're in luck this morning because we have two science instructors from the Chabot Space and Science Center. Immediately on my left is Ignacio, and then we have Tobi Thomas. And you're going to tell us about some of these things that you're going to show us what happens to them when all of a sudden the atmosphere is taken away. Now, first of all, just explain to us, what is atmosphere?
Atmosphere is a layer, well, in our case here on Earth, that has all the stuff that allows us to be here. It provides us the air that we breathe. It also provides the medium in which our words can transfer from me to you and vice versa.
So, Tobi, we're really talking about a void here, aren't we?
Yeah, we're talking about a void. So actually what we're going to be creating a vacuum. Yeah. So in essence, we're going to be taking all the different things that comprise to make up our atmosphere. We're going to remove it.
All right, let's go ahead and see. You're going to use a household item. Start with a balloon.
Yeah, first thing we're going to put in there, we're going to stick it here at the top.
And then you're going to fire up the generator. Look at that. Now, why did the balloon respond in that way?
So the balloon got bigger because when we removed the atmosphere, we also removed the pressure. All the stuff that's pushing the air towards the center of the balloon is now trying to escape because there's no pressure. That's been alleviated.
And now that we see, after we've spoken for a few seconds, the balloon is beginning to regain its shape.
That's right. That's because all of the shape of the balloon is taking its place because the air has...
essentially starting to return because I released the valve and the atmosphere is returning it back into it. So
okay, so the atmosphere, so to speak, is returning to the chamber.
Yes.
Okay, what does the generator do? It just sucks the air out of everything?
That's right.
Yeah, it sucks the air out of it.
That's my unscientific description of what's going on here. Okay, so we see what happens to a balloon. Tell us what's going to happen next when we put in the water. Go ahead and show us.
Do you have any ideas what might happen to the water?
I'm guessing that it's going to contract. No.
Well, let's check it out.
All right.
In science, it's always important to make educated guesses, right?
Or uneducated in my case. Go ahead. I can see a lot of... There we go. Now we can see it bubbling up. What's happening here? Explain what's going on.
So it's the same idea. There's pressure that allows the water to retain its liquid form. But when we remove that pressure in the vacuum chamber, it vaporizes.
Okay.
But here's the tricky thing.
Yeah.
So as
You're releasing the pressure.
We're letting everything back in.
Right. Okay.
And so you saw that the water was boiling, right?
Right.
So now I would like to invite you to stick your finger.
I thought we were friends. It's cold.
Yeah.
Yeah.
So
it's amazing how quickly it returns back to that temperature.
Well, it never got high.
Yeah, the temperature actually didn't change because boiling is not actually really having to do with temperature. Boiling is just when it changes states from once enough surface tension allows it and it matches the atmosphere, then it changes into the next state, which is the gas state.
You know, it's funny because most people watching this would have thought, well, it's bubbling up, it must be boiling.
It must be boiling.
That's fascinating.
And so we can actually tie this to what's going on other planets besides our own.
Mars.
So Mars, for example.
Yeah.
Yeah, definitely Mars, where we have the polar ice caps and we have different things in water. It can exist in only two states on Mars, pretty much. We found that it can sit in the solid state and also in the state
as water vapor, as gas. In the atmosphere of Mars, there are traces of water vapor.
And what does that tell us? Why is that important?
Well, that's important because, well, you could simply tell by the geography of Mars, by its landscape, that there was water there once upon a time, but the water is no longer there.
Right.
We know that it's there because there are canyons that were shaped by water, and also the polar ice caps as well.
Go ahead and let's do the next one here. This is a marshmallow, which I'm fascinated to find out what happens here when you put marshmallow in a zero atmosphere situation. expanding. And what's causing it to do that?
Well, what do you think? Based on the observations that we've done before.
That's amazing. That's amazing to see that it can expand that quickly.
So in the marshmallows, they're little air pockets. And the same thing, when we remove the pressure, the air is trying to escape, so therefore expanding the marshmallow. But then when we let the pressure back in, because the air was leaving the marshmallow, if we left it in longer, the marshmallows would have actually started to shrink.
That is fascinating. Thanks so much for sharing that. Real quickly, what have you got going on in Chabot?
We have a few different things. We have a really cool event coming up called the RoboFest.
Oh, that should be fun.
For all ages, the youngest of us to the oldest of us, you get to learn all the ins and outs about robots, how they're made, and actually gonna have some competitions with some robots.
Oh, that sounds fantastic. So if you want to learn more information, just go on to the Chabot Space and Science Center website, learn everything about it. Thanks a lot for joining us, you guys.
Thank you.
We'll be right back.